When we think of stars, we often picture small, twinkling lights in the evening sky. This is how we typically perceive them from Earth. However, stars are vastly different from what we see. Some are much larger than we imagine. Take Betelgeuse, for instance. This star is far more massive than our Sun, and for years it has intrigued scientists. Recently, Betelgeuse has exhibited unsettling behavior, prompting concern among researchers and experts alike. Join us in this video as we explore the fascinating news about Betelgeuse, its potential destruction predicted by the James Webb Space Telescope, and how this development might impact our world. Betelgeuse is a stellar wonder, an enormous star that has captivated astronomers for centuries. The Greek astronomer Ptolemy was among the first to discover it. This massive star is so bright that it can be seen from Earth, particularly in the winter sky. If you're interested in constellations, you might have noticed it. Betelgeuse marks the top left shoulder of the Orion constellation and stands out as a reddish-orange star. Though it is one of the oldest and brightest stars in the night sky, its brightness is not constant. It fluctuates, which is one of its most unique features. In fact, Betelgeuse is located around 600 light-years away from Earth, far beyond most of the stars we observe in the sky. To put it in perspective, the closest star to us is 4.2 light-years away, which means if you could travel at the speed of light, it would still take over 4 years to reach it. But Betelgeuse, at 600 light-years away, is significantly more distant. Even though we can't travel that quickly, its sheer size and brightness allow it to shine clearly in our sky from such a distance. Betelgeuse is roughly 500 times larger than our Sun, with a radius estimated to be more than 1,000 times that of our star. Despite its size, Betelgeuse appears as a disk in space when viewed through advanced telescopes, unlike most stars, which appear as tiny points of light. This disk-like appearance is thought to be caused by reactions occurring in the star's outer layers. In terms of mass, Betelgeuse is about 12 to 19 times heavier than the Sun. While it's challenging to determine the exact mass due to the lack of orbiting planetary bodies, scientists estimate that it is still much heavier than our Sun. Betelgeuse's luminosity fluctuates between magnitude 0 and plus 1.6, meaning it is up to 100,000 times brighter than our Sun at its peak. No wonder it's known as a red supergiant. However, the brightness is not stable. It varies due to the star's internal processes. Betelgeuse expands and contracts periodically, growing brighter when it expands and dimming when it contracts. This pulsation can last anywhere from 10 to 100 days or even longer. One of the star's most fascinating characteristics is its magnetic spots. These dark regions on the star's surface have stronger magnetic fields than the rest of the star, restricting the flow of hot gas to the outer layers and causing the star to cool in those areas. These spots are far larger and more numerous than those on our Sun. To give you an idea, some spots on Betelgeuse are twice the size of Earth. The star also has a magnetic field about 10 times stronger than the Sun's, which causes the gases on its surface to form loops and arcs. With a surface temperature of around 3,500 Kelvin, Betelgeuse is much cooler than our Sun, which contributes to its dimmer red hue. Interestingly, Betelgeuse wasn't always red. Around 2 million years ago, it was a yellowish star similar to our Sun. Over time, it began to shift to a more orange and red hue, indicating that it is aging. This has led astronomers to believe that Betelgeuse is in the final stages of its stellar life cycle. Betelgeuse radiates about 100,000 times more energy than the Sun. If it were closer to Earth, it could easily outshine the Sun, and we would be able to see it during the day. If Betelgeuse were to replace the Sun, it would consume or displace the Earth and the other inner planets due to its enormous size. Moreover, it produces significantly more radiation than our Sun, which would make it a formidable counterpart to our star if it were nearer to us. Despite its distance of 600 light-years, Betelgeuse is still visible to the naked eye in the night sky, which is remarkable considering how far away it is. Our Sun, in comparison, is just 8.3 light-minutes from Earth, which is why it appears so much brighter. If Betelgeuse were any closer, it would be visible during the daytime as well. Its immense size and brilliance make it one of the most striking stars we can observe. In summary, Betelgeuse, located in the Orion constellation 600 light-years away, is a massive, brilliant red supergiant. Its size and fluctuating brightness make it a fascinating object for astronomers, but its behavior, particularly the recent developments observed by the James Webb Space Telescope, has sparked concern about its eventual fate and what it could mean for Earth. Unlike our Sun, which maintains a relatively steady luminosity over time, Betelgeuse undergoes periodic fluctuations in its brightness. These variations are attributed to pulsations within the star, driven by changes in its internal processes. At its peak brightness, Betelgeuse can shine 16,000 times more intensely than the Sun, but during dimming episodes, its luminosity can significantly decrease. The star's variability has been a focal point of extensive study among astronomers. Observations over the centuries have recorded these fluctuations, providing crucial insights into Betelgeuse's life cycle and physical characteristics. Understanding the mechanisms behind Betelgeuse's brightness changes is vital for unraveling the complexities of stellar evolution and the behavior of massive stars. Betelgeuse has a surface temperature of approximately 3,500 Kelvin, which is relatively low for a star of its size. This contributes to its distinctive red-orange hue. When studied through spectroscopy, the star's spectrum reveals absorption lines that indicate the presence of various elements in its atmosphere, including hydrogen, helium, and heavier elements produced by nuclear fusion processes deep within the star. Betelgeuse also exhibits strong magnetic activity on its surface, characterized by the presence of dark magnetic spots. These regions, where the star's magnetic field is significantly stronger than in surrounding areas, impede normal convection processes that transport heat from the star's interior to its surface, resulting in cooler areas on the star's surface. Studying these magnetic features provides valuable insights into stellar magnetism and its impact on the dynamics of massive stars. Betelgeuse has been known to astronomers for centuries. Ancient stargazers from various cultures, including the Greeks, Egyptians, and Chinese, recorded its position and noted its brightness variations. In Arabic astronomy, the star's name, Yad al-Jawza, meaning the hand of, reflects its prominence in the constellation and its noticeable variability. The star's fluctuating brightness has inspired numerous legends and cultural references throughout history. In Greek mythology, Betelgeuse marked the shoulder of Orion the hunter, and its changing luminosity was often interpreted as a sign of strength or mood, influencing stories and beliefs across different cultures. Beyond its cultural significance, Betelgeuse has been a focal point for scientific study. Observations using telescopes and spectroscopic instruments have provided detailed data on the star's physical properties, such as its size, mass, temperature, and chemical composition. These observations have advanced our understanding of stellar evolution and the life cycles of massive stars. Recent observations of Betelgeuse sparked renewed interest and speculation among astronomers. In late 2019 and early 2020, the star experienced significant dimming episodes, causing its brightness to decrease substantially. These dimming events attracted the attention of the astronomical community, leading to theories about their underlying causes. One prominent theory is the possibility that Betelgeuse may undergo a supernova explosion in the near future. Supernovae are catastrophic explosions that occur when massive stars exhaust their nuclear fuel and undergo gravitational collapse. If Betelgeuse were to go supernova, it would release an immense amount of energy, becoming one of the brightest objects in the night sky, even visible during the day. The potential for Betelgeuse to go supernova has captured both public imagination and scientific interest, given its proximity and visibility. Astronomers continue to monitor the star closely, using telescopes and space-based observatories to gather data on its behavior and evolution. Betelgeuse's status as a red supergiant provides valuable insights into the later stages of stellar evolution. These stages involve the fusion of heavier elements in the star's core, leading to the production of elements like carbon, oxygen, and iron. Studying Betelgeuse and similar stars helps astronomers understand how stars evolve and enrich the universe with chemical elements essential for the formation of planets and life. In addition to its role in stellar evolution, Betelgeuse contributes to our understanding of cosmic dynamics and the role of massive stars in shaping galaxies. Supergiant stars like Betelgeuse play a crucial role in the chemical evolution of the interstellar medium, providing the heavy elements necessary for the formation of new stars and planetary systems. Betelgeuse's variability and complex behavior challenge existing astrophysical models and theories. Understanding the mechanisms behind its pulsations and brightness fluctuations requires advanced simulations and observational techniques. By testing and refining these models, astronomers can improve our understanding of stellar processes and their broader implications for cosmic and galactic evolution. Future observations of Betelgeuse will continue to play a significant role in advancing our knowledge of stellar evolution and supernova dynamics. Long-term monitoring efforts using ground-based observatories and space telescopes will provide ongoing data on the star's variability, magnetic activity, and potential for a supernova event. Advancements in observational technology, such as next-generation telescopes and adaptive optic systems, will enhance our ability to study Betelgeuse and other distant stars in greater detail. These technologies will allow astronomers to probe deeper into the mysteries of stellar interiors and atmospheric dynamics. Combining observations across various wavelengths of light, from radio waves to gamma rays, will provide a comprehensive view of Betelgeuse's physical processes and its interactions with its environment. Multi-frequency studies are crucial for unraveling the intricate relationships between magnetic fields, stellar winds, and the surrounding interstellar medium. Betelgeuse remains a cornerstone of cosmic research, offering valuable insights into the life cycles of massive stars, cosmic dynamics, and the origins of chemical elements in the universe. Its variability, historical significance, and potential for a supernova event make it an intriguing subject for ongoing and future investigations. By continuing to explore and monitor Betelgeuse, astronomers will deepen our understanding of stellar evolution and the dynamic processes that shape the cosmos. In the night sky, Betelgeuse, also known as Betelgeuse, stands out with its reddish-orange hue, which is characteristic of red giant stars nearing the end of their life cycle. With a surface temperature of about 3,500 Kelvin, it's relatively cool for such a massive star. Like other red giants, Betelgeuse has exhausted the hydrogen fuel in its core and is now fusing heavier elements, a process that generates energy and causes the star to expand. Betelgeuse's surface is marked by complex physical phenomena, including large, dark magnetic spots. These spots, which are significantly larger than those found on the Sun, are regions of intense magnetic activity that restrict the flow of hot gases from the star's interior to its surface, resulting in cooler areas. This star has been known since ancient times and has been observed and recorded by many civilizations. Its prominence in the night sky, especially during the Northern Hemisphere's winter months, has made it a key feature in star constellations and mythology. Recently, Betelgeuse has drawn increased scientific attention due to unusual dimming episodes that began in late 2019 and continued into mid-2021. During these periods, the star's brightness dropped to unprecedented levels, sparking discussions among astronomers about its potential fate. Although such dimming events are not uncommon for variable stars like Betelgeuse, the extent and duration of these episodes have led to speculations about the possibility of it undergoing a supernova event in the relatively near future. Supernovae are catastrophic events that occur when massive stars reach the end of their life cycles, rapidly collapsing and then exploding. These explosions release enormous amounts of energy, temporarily outshining entire galaxies, and generate heavy elements that enrich the interstellar medium. The prospect of Betelgeuse becoming a supernova has captivated scientists, especially given its visibility and proximity in the night sky. The study of Betelgeuse continues to offer valuable insights into stellar evolution, the dynamics of massive stars, and the broader processes that shape galaxies and the universe. Its size, brightness variability, and complex magnetic field make it a compelling subject for ongoing astronomical observation. Betelgeuse, located approximately 600 light-years from Earth in the Orion constellation, is one of the most brilliant stars in the night sky. Not only is it notable for its luminosity, but also for its massive size and unpredictable behavior. This supergiant star has fascinated both astronomers and amateur stargazers for centuries, providing valuable information about stellar evolution, cosmic distances, and the powerful forces shaping the universe. Classified as a red supergiant, Betelgeuse is in the late stages of its stellar life cycle. Its radius is estimated to be about 500 times that of the Sun, meaning it would extend beyond the orbit of Mars if placed at the center of our solar system. However, despite its enormous size, Betelgeuse is not the most massive star. Its mass ranges from roughly 12 to 20 times that of the Sun, depending on various estimates and calculations. One of Betelgeuse's most fascinating characteristics is its variability in brightness, adding to its intrigue as a subject of ongoing astronomical study.